Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about. Electric current, electric current, electric current. CBSE Grade 10 Physics. So now we'll discuss about electric current, right? Yes. Electric current. So discussing about electric current. So rate of law of charge I equal to Q by T. I equal to Q by T. I'm considering. So I equal to Q by T. Electric current is nothing but rate of law of charge. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. The rate of law of charge. The rate of law of charge is called electric current. The rate of law of charge is called electric current. So I'm considering here. This is ampere. This is ampere. Okay, ampere. And I am considering this the coulomb, and this is the time, second. Okay, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. I equal to 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per second. So current is nothing but I equal to Q by T. I equal to Q by T. The rate of flow of charge. The rate of flow of charge is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Okay. So now I am considering here. So charges are moving inside of the conductor. Today we'll discuss few more questions related to electric current. So from these days I'm explaining the concept. Now we will discuss about few more questions also. Few questions also will discuss related to electric current. Okay, now we will discuss. So 1 amp. So here I am taking positive charge, negative charge, positive charge, negative charge. So charges are moving inside of the conductor. So here charges are not only moving one or two, there are many charges will move. Many charges will move. That's why it is called quantization of charge. That is nothing but quantization of charge. N equal. So we are taking Q equal to plus or minus Ne. Q equal to plus or minus Ne. Okay. So here I am taking plus or minus Ne. So that is nothing but okay. So n is the number of charges. Number of charges are moving inside of the conductor. Number of charges are moving inside of the conductor. Okay, so that's why I'm taking plus or minus. Positive charges are moving inside, at the same time negative charges also will move. Both the positive charges and negative charges both will move. That's why we are taking plus or minus any. So q equal to plus or minus any I'm taking. N is the number of charges. Okay, n is the number of charges we are considering. Now one electron on one electron 1.6 into 10 power minus 19 coulomb. So in so this is very important. Make sure that you are practicing this value. So this value is very important. This value is very important. Okay, so practice that value on 1 coulomb, on 1 coulomb, on 1 coulomb. Okay, 1.6 into 10 power minus 19 coulomb. So on one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? We will discuss now. So I'm considering here. In 1 coulomb, 1 by 1.6 into 10 power minus 19. So if you are taking 1 by 1.6 into 10 power 19 equal to 1 by 1.6 into 10 by 10, that is 10, 16 into 10 power 19, then you'll get 0.625 into 10 power 19. Then in 1 coulomb, 6.25 into 10 power 18 electrons. Okay, so this is very important. In 1 coulomb, 6.25 into 10 power 18 electrons are present. On one electron, 1.6 into 10 power minus 19 coulomb. Okay, so this is about electric current and quantization of charge. Okay, so this is about electric current and quantization of charge. Electric current and quantization of charge. Now we will discuss few questions related to this one. Okay, chalo then. So here, what is SI unit of electric charge? SI unit of electric charge is coulomb. Okay. How many electrons constitute 1 coulomb of charge? So we know how many electrons. Electrons are 6.25 into 10 power 18 electrons. Okay. Define electric current and SI unit of electric current. The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. State the relationship between 1 ampere and 1 coulomb. Okay, state the relationship between 1 ampere and 1 coulomb. 1 ampere equal to 1 coulomb per 1 second. Right? Okay, there is a question related to electric current. We will discuss that one. So I equal to Q by T I explained, right? So related to that one, one question is there. So we'll discuss that question. Chalo then. So this question comes for 2 marks. Try to solve it. So what is the answer? Anyone can tell the answer? Can you tell anybody? What is the answer? So 2 minutes or I'll give 4 minutes. Chalo then go for 5 minutes. Easy only. So no difference. No. So easily we can do it. Yes. Okay, coming to the answer. So here an electric source can supply of, here the question is this one, this the question. This the question, check once. So an electric source can supply of this the charge, electric current but drawn, so this the current. Find the time which electric source will be discharged. So charge is given, charge is coulomb, that is Q is given. So Q is given, Q equal to Q equal to 500 coulomb. First one. So current is given, that is 25 milliampere. So 1 milliampere equal to 1 milliampere equal to, so formula is normally 1 milliampere equal to 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere, right? Yes. Now I equal to Q by T. So current I am taking 20 in 25 into 10 power minus 3 in equal to 500 by T. So T equal to coulomb, 500 coulomb. So time is, current is milliampere, 20 into, so T we have to find out. So find out how much you'll get. Try to do it. Okay. Okay. Chalo the next question. Oh, Kashyap. Thank you so much, Kashyap. Okay, now we'll see one more. So this question is very, very important. So actually I explained that question. That is, the charge possessed by an electron is 1.6 into the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. 1 ampere. So we need to find out this one. Check once. Okay. Still it is there. So related to resistivity and resistance questions are there. And here also V equal to I are related to Ohm's law. Okay. So I'll explain. And related to diagram also, they will give the values like that. So ammeter, resistor, resistance, ohm. You have following material: an ammeter 0 to 1 ampere, voltmeter 0 to 3, a resistor 20 ohm, a key, a rheostat, battery and 3 ohm, 7 connecting. So like this devices they will give like electrical appliances. So they will ask to draw the circuit diagram. So that question you have to draw. And next one. Resistance of ammeter and voltmeter. Resistance of ammeter is resistance. Okay. Resistance of ammeter must be ideal ammeter. Ideal ammeter resistance is 0. Ideal voltmeter resistance is infinity. Ideal ammeter resistance is 0. Ideal voltmeter resistance is infinity. Okay, so now we'll discuss few questions related to that. I'll discuss a few more concepts. Based on that one, we will do problems. Okay, so be ready now. Now, we'll discuss about electrical appliances, cell, battery, ammeter, voltmeter, resistor, rheostat. Okay, so we'll discuss now. Are you ready? Be ready. Come on. So I'm taking this first one, cell. Cell. Second one is cell, battery. So switch, open switch, closed switch. So they will ask the question related to this one. They will ask one question related to this one. That is, okay. Cell, battery, open switch, closed switch, closed switch. Next one, resistor, resistor, rheostat, cell, battery, open switch, closed switch. Cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, bulb. So these are the electrical appliances. Electrical appliances. Electrical appliances. Yes or no? Based on this one question will come. Based on this one One question will come. Yes or no? So they will give this one. They will give this one. They will give this one. Okay. So any of these appliances they will give. They will ask to draw this one. Give the name of it. Give the name of it. Resistor. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomenon of opposing the electric current. Resistance is the phenomenon of opposing the electric current. Resistor is a device which is used to oppose the electric current in the circuit. Resistance. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomenon of opposing the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. Yes or no? Now we will discuss few more points. Ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. So you can see ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Voltmeter is used to measure the potential difference. Ammeter will be connected in series to the circuit. Voltmeter is connected parallel to the circuit. Yes or no? So this is about ammeter and voltmeter. Next one, we are going to discuss about one more. So electrical circuit. Electrical circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Conventional current and electric current. Conventional current is nothing but the flow of positive charges will be considered as a conventional current. Flow of negative charges, flow of electrons will be considered as a electric current. Flow of positive charges will be considered as a flow of positive charges. I'm considering electric current. Flow of electrons will be considered as a electric current. So positive charges will move from positive terminal to negative terminal. Electrons will move from negative terminal to positive terminal. Yes or no? Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Yes or no? Now we will go to the one more. That is, we'll see now. Electric circuit. Electric circuit, electric circuit, electric circuit, electric circuit. Here I'm considering here. So battery. So conventional current is nothing but flow of positive charges. Flow of positive charges will be considered as conventional current. Flow of electrons will be considered as a electric current. Flow of positive charges will be considered conventional current. Flow of electrons will be considered electric current. Positive charges will move from Positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential, whereas negative charges will move from low potential to high potential. Low potential to high potential. Once again, positive charges will move from positive terminal to negative terminal, whereas electrons will move from negative terminal to positive terminal. So positive charges will move from positive terminal to negative terminal. Negative charges will move from electrons. Electrons will move from negative terminal to positive terminal. Okay. So this is about a conventional current. Conventional current is nothing but flow of positive charges. Electric current is nothing but flow of electrons. Flow of electrons. So that is about. So that's why we are considering now. We are going to the next one, that is Ohm's law. Related to this one, related to conventional current and electric current. So there is one question. There is one question. Will electron will move from negative terminal to positive terminal or positive terminal to negative terminal? Electrons will move from positive terminal to negative terminal to positive terminal. Okay. So that question they will ask. And one more question is, they will give electrical appliances. They will give electrical appliances. Suppose if you am taking here, so related to this, they will ask few questions. One is related to current, potential difference is given, current is given. We need to find out resistance. V equal to IR formula. So that is Ohm's law. Okay, so that we will discuss. Ohm's law will discuss. Actually, there is one question. Yes, you have following material: an ammeter 0.1 ampere, a voltmeter 0.3 volts, a resistor 20 ohm, a key, a rheostat, a battery of 3 volts and 7 connecting wires. Using this material, draw a labeled circuit diagram to study the dependence of potential difference across the resistor on the current passing through it. Okay, so they will ask about this one. They will ask about this one, that is, so by giving the electrical appliances, you have to draw the electrical circuit. That is nothing but schematic diagram. Okay, na? You have to draw the schematic diagram. And here one more. So they will they given the symbols. What does the following symbols represent? Here you can see these are the wire crossing, rheostat and resistor. So here you can observe this is the wire crossing, not joining. This is the wire crossing, rheostat and resistor. Okay. So related to this one they will ask. Related to this one they will ask. Okay, and one more also they will ask about related to current. Here I equal to Q by T, right? I equal to Q by T. Sometimes they will give electron. So like a current they will give, charge they will give, they will ask to find out electron. Okay, number of electrons. So on one electron how much charge we know, right? 1.6 into 10 power minus 19 coulomb. So related to that one also they will ask. And yes, should the resistance of ammeter be low or high? Give the reason. Ammeter resistance must be always low. We cannot take high, because if ammeter is not allowing the current, then how it will go? How the remaining appliance will work? Ammeter should have low resistance. Ammeter should have low resistance. Then only it will allow the current to pass, right? Then so it can measure also. The ideal ammeter resistance is 0. Ideal ammeter resistance is 0. Ideal voltmeter resistance is infinity. Okay. And ammeter is connected in series combination. Voltmeter is connected in parallel combination to the circuit. Okay. What happens to the resistance of a conductor when temperature is increases? Very, very important question. What happens to the resistance of a conductor when temperature is increases? Definitely temperature will increases. Temperature increases, resistance also increases. What happens? The question is, what happens to the resistance of a conductor when temperature is increased? When temperature increases, resistance also increases. Resistance also increases. What is an electric circuit? What is an electric circuit? Question: what is an electric circuit? Electric circuit is nothing but electric circuit, a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay, distinction between open circuit and closed circuit. Open circuit means switch, I said, right? Switch. If switch is open, that is open circuit. If switch is closed circuit. That's enough. List in a tabular form two differences between voltmeter and ammeter. Voltmeter is used to measure the potential difference. Ammeter is used to measure the current. Voltmeter is used to measure the potential difference. Ammeter is used to measure the current. Okay, now. So now here voltmeter is connected in parallel combination to the circuit. Ammeter is connected in series combination. Voltmeter is connected in parallel combination. Ammeter is connected in series combination. Okay, these are the questions. These are the very, very important questions. One more. Yeah, actually it is related to potential difference. And one more question. So total number of electrons are given. I will give one question. Try to do as a homework. Okay. Two questions I will give. 2 questions I'll give, so try to do as a homework. Okay na? Chalo then. So this is the data they given. How to find out the current? How to find out the current? So I'm giving the data. I'm giving the data. So question I'll read once. That is, a total of 6 into 10 power 46 electrons flow through a current copper carrying conductor when connected through an electron external power supply for 20 seconds. Find the value of current in the conductor. Find the value of current in the conductor. Okay, so that is a question. That is a question. So in the question they given electrons. Electrons are given. So electrons are given, time is given, current we have to find out. How to find out? So we know the formula I equal to Q by T. That is Ne by T. So we know one electron 1.6 into 10 power minus 19 coulomb. So on one electron 1.6 into 10 power minus 19 coulomb, and one electron 1.6 into 10 power minus 19 coulomb. Okay. So now we know this one I equal to I we have to find out. So N we know 6 into 10 power 46. N we know 1.6 into 10 power minus 19, and the time we know 20 seconds. So do this. That's enough. Okay, so next we are going to the one more question. Next, So ohmic related to ohmic, non-ohmic, we will discuss power also. Okay, that's enough. Related to this one, so we'll discuss Ohm's law. So we'll discuss about Ohm's law, then we will see Ohm's law, Ohm's law, Ohm's law. So Ohm's law we'll discuss now. Ohm's law is nothing but the potential difference. The potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. At a constant temperature. Okay. So V is directly proportional to I. V equal to IR. V equal to IR. V equal to IR. Okay. Now, what are the materials required for doing this activity? Materials required. Materials required. Materials required. Materials required. First one is 4 cells, 1.5 volts each, 1.5 volts each. Taking 4 cells of 1.5 volts each. Second one, nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nichrome wire. Nichrome wire is an alloy of 0.5 meter length. And coming to the third one, okay, so I'm taking ammeter. Fourth one is voltmeter. Ammeter and voltmeter. Fifth one, switch. So seventh one, sixth one. Sixth one is connecting wires. 4 cells 1.5 volts each, nichrome wire is 0.5 meter, ammeter, voltmeter, switch, connecting wires. So procedure. Procedure. Procedure is procedure. First one I am taking one cell. We have to take one cell and note down the reading of ammeter and voltmeter. Connect to two cells. And repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay. So draw the tabular form. So first proceed. First you have to Ohm's law. The potential difference across the metallic conductor. The potential difference across the ends of the metallic conductor. The potential difference across the ends of the metallic conductor is directly proportional to current flowing through it. V equal to IR. Materials 4 cells 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. So I am taking 4 cells. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch. So we can also take this is key. Okay, connecting wire. First you have to connect one cell and note down the reading of ammeter and voltmeter. Next you have to connect to two cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention in the tabular form given below. Mention in the tabular form given below. So I hope you have so many doubts regarding my costume. So you can check my channel. Once you go through the channel, visit my channel, check all the videos in my channel, then you will only get to know reason behind of this costume. So definitely I hope you'll get the answer. So okay, now you can consider here. So serial number of cells, current, ammeter reading, voltmeter reading, V by I. That is the resistance. Okay. SI unit of resistance is ohm. Ohm's law gives the resistance of. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. R equal to V by I. Okay, so now this is about Ohm's law, materials, procedure. So circuit diagram, this is schematic diagram, circuit diagram. If you draw the graph for VI, so V on y-axis, X on V on y-axis, current on x-axis. So VI graph gives the linear for ohmic conductor. For non-ohmic conductors, the graph is curved. Okay. So this is about Ohm's law. Next one we will discuss about resistance and resistivity. Resistance and resistivity we'll see. the potential difference across the ends of the given metallic conductor V is directly proportional to V equal to IR, R equal to V by. So materials 4 cells 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. Nichromere is an alloy of nickel, chromium, manganese and iron metals. Ammeter and voltmeter, switch and connecting wires. So first you have to connect one cell and wrote down the reading of ammeter and voltmeter, and connect the two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4 and mention in the tabular form given below. Okay. Okay. So next one we are going to the one more, that is so resistance. Resistance depends on length of the conductor. Resistance depends on length of the conductor. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. So here R is a resistance, rho is resistivity. R is the resistance, rho is resistivity. Rho is resistivity. Rho equal to RA by L. Ohm meter square by meter. Ohm meter might get cancelled, then you will get ohm meter. So resistivity is equal to ohm meter. Resistivity is equal to ohm meter. Okay, SI unit of resistivity is ohm meter. So very important, very important. One check it. Okay, so I'm considering here. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So rho equal to RA by L. So ohm meter square by meter get cancelled. We'll get ohm meter. Okay. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Yes or no? So this is about resistance. Factor depends on resistance. So thank you so much for joining and listening and attending my class. And thank you for giving me an opportunity to teach the class. So this is Eva Siva sir from Student Brand. Thank you so much. We'll see you in the next class. Thank you.